Hello and welcome to Foundations in Pre-Cal 10. This is lesson 2 on drawing and interpreting graphs in real life situations. So what we're going to do today is just basically draw a graph, talk about how we know which variable goes on which axis or where we put each of the numbers, and then reading that information or reading information from graphs, okay? So in any situation, we have a dependent and an independent variable. The dependent variable is always graphed on the y-axis. It's the range and it depends on the other variable. The independent variable is always graphed on the x-axis. It's the domain and it drives the change in the situation. I once heard somebody refer to it and say the wall depends on the floor. So if you're building a house, you build the floor first and then you build the wall, right? And the wall depends on the floor. So the wall or the floor depends, so it's the dependent variable, and the floor is the independent one, okay? Just a reminder that we have both continuous and discrete data. So continuous is where the data points would be connected, and discrete is where they are not connected, okay? So we'll talk about when we connect, when we don't connect. Okay, so let's look at this example. Sonia can ride a bike at a constant speed for a long time. The table shows some data that was collected. So after 1 hour, they're at 20 kilometers, 2 hours, 40, 3, 60, and so on. Which variable is dependent and which is independent, okay? Well, the dependent variable, the one that is changing all of the time, is the distance. It depends on how far, how long you've been driving for, right? So the dependent variable is the distance, and the independent variable is the time. Okay, so we're going to draw a graph of this information. So what I want you to do is take a ruler and you're going to draw your x and y axis on. I'm just going to pause the video and do that, and I'll be back in just a second. All right, so there we have our lines drawn. Make sure you use a ruler to draw them. And we've decided that the dependent variable is the distance. That is what is going to be graphed on the y-axis. So we're going to label that as distance. And on the x-axis, we're going to put time. Toughest part of any graph is determining how to scale it. So we need to be able to go up to 120. So I think if we go up by tens on the y-axis, that will get us. So I always find it super cluttered though if we label every single point. So I'm going to label 20, 40, 60, 80, 100, and 120. Okay, and then our time in hours, we need to go only to 6, so we're going to want to have more than 1 square per hour. So let's go 4 squares an hour. That would be every 15 minutes as a square. So 1 hour, 2 hours, 3 hours, 4 hours, 5 hours, 6 hours. Okay, and then we're going to plot the points. So at 1 hour, we are at the 20 kilometer mark. At 2 hours, we're at the 40 kilometer mark. 3 hours, we're at 60. 4 hours, we are at 80. 5, we're at 100. Oops, that one should be there. And 6, we're at 120. Okay, so now we have to decide whether it's discrete or continuous data. So basically we ask ourselves, like when you're driving down the road, would it be reasonable that you are at a certain position at, say, the 15-minute mark? Like, would there be a line there? And the answer is yes. So then, therefore, it is continuous. We want to draw a line. So again, take your ruler, connect your dots. Don't worry about having to make it go through 0, 0. If it does, that's fine. But let's make sure we use a ruler. I'm going to pause, grab my ruler, and do that. Okay, so there we have our information. So we said this is going to be continuous. And now we answer questions about it. So it says, does Sonia ever stop over the 6 hours? No, she doesn't, right? She keeps going forever and ever. If she was to stop, that line would get horizontal because time would be passing, but she wouldn't be moving. How far does she travel? Well, in the 6 hours, the last dot here, if we look across to the distance, that is 120 kilometers. And about how far after 3.5 hours. So we have to go to 3.5 hours, look up to our graph, and go over to the side. That's about 70 kilometers. Okay, that's really all there is to it. So this little lesson is kind of nice, hopefully okay. You're just going to plot points, read graphs, and go from there. So you go ahead and do the next 3 questions on your own.